Okay, in this video we're going to take a look at how to use the dot product to find the angle measured between two vectors. So if we draw vectors v and w with the same initial point, then the angle theta between them, some various angles between them are illustrated below. So for instance, if v and w are parallel, then the angle between them is 0 degrees, so they don't make any opening at all. We could have an angle that's between 0 and pi, or 0 and 180 degrees. And if they're opposite vectors, in other words, they're pointing in exact opposite directions, then the measure of the angle between them is pi, or 180 degrees. So today we're going to look at how to calculate the angles, especially for ones that are not parallel and not opposite, but somewhere in between. So more or less this second case here. So geometrically, the dot product between two vectors, we took a look at how to find it using the coordinates or the components in the last video. But vector v dot vector w is the magnitude of vector v times the magnitude of vector w times the cosine of the angle between them. So for instance, if we have, let's say v, the angle between them is 0, so whatever the length of v is, times whatever the length of w is, times the cosine of 0 will just give us what the magnitude of vector v times vector w is as the dot products. So here we have vector v and vector w have the same initial point. They have an angle. Going back to our section on vectors, that when they have the same initial point, the side opposite that angle that they make is vector v minus vector w. So if we look at it in terms of lengths, then this is the magnitude of vector v, this length is the magnitude of vector w, and this length here, opposite the angle, is the magnitude of vector v minus vector w, and this is reminiscent of the law of cosines. So by the law of cosines, this side squared equals magnitude of v squared plus the magnitude of w squared minus 2 times the magnitude of v times the magnitude of w times the cosine of theta. So this is just law of cosines applied to this triangle. By example 2 from the last video, we saw that vector v minus vector w squared is the magnitude of vector v minus 2 times the dot product of v and w plus the magnitude of w squared. So if we equate this expression and this expression, since they're both equal to the magnitude of v minus w squared, they have to be equal to each other. And doing a little bit of calculation and solving for cosine of theta, we'll get the cosine of theta is vector v dot vector w divided by vector v times vector w, or the magnitude of vector v rather, times the magnitude of vector w. So to find the angle between the two vectors, if we know what this result is, we can just use inverse cosine to find it. So it's the inverse cosine of the dot product of v and w over the magnitude of v times the magnitude of w. Or another way to look at it is v over the magnitude of v, that's your unit vector for vector v. So again, that's what that little caret represents. Vector w divided by the magnitude of vector w, that is your unit vector for vector w. So as an alternative, a much easier way of looking at this than is this, although they're the exact same things. So example 3, we're going to find the angle between each of the following pairs of vectors. So we're going to start with vector v is 3, negative 3 square root of 3, and vector w is negative square root of 3 and 1. So first up, let's find the dot products like we did in the last video. So 3 times negative square root of 3 plus negative 3 square root of 3 times 1. When we do that calculation, we get negative 6 square root of 3. So that's our numerator for inverse cosine. And the magnitude of vector v, 3 squared plus, again, ignore the negative, 3 square root of 3 squared, will give us 9 plus 27 is 36. And I'm going to recommend not simplifying these just in general, and we'll see why in a little bit. But same thing with the magnitude of w, square root of 3 squared plus 1 squared is square root of 4. Again, I know this is 6 and I know this is 2, but in terms of the formula, it's not always going to have these nice perfect squares that you take the square root of. So just, even though we could simplify this, don't bother simplifying it because it's not going to make a difference in your calculator anyway. So our angle between them is the inverse cosine or arc cosine of the dot product, -6 square root of 3, over the square root of 36 times the square root of 4, which we could just make the square root of 36 times 4 inside one square root. And when we calculate this, we'll get 150 degrees, or 5 pi over 6. Part B, we have 2, 2, and 5, -5. So the dot product between them, 2, 5, 2 times 5, and 2 times -5 is 0. So our magnitude of vector v, 2 squared and 2 squared, is 8. And again, we'll just leave it as the square root of 8. We won't make it 2 square root of 2. Magnitude of w is square root of 50. And our angle between them, 0 divided by any non-zero number is 0. And the inverse cosine of 0 is 90 degrees, or pi over 2. So these two vectors, if we were to graph them, they would make a 90-degree angle. They'd be perpendicular, or as we call in vector land, orthogonal. Finally, example 3c, we have 3, -4, and 2, 1. So first, the dot product between them, 3 times 2 and -4 times 1 gives us 2. The magnitude of vector v is square root of 25. Again, don't simplify it. The magnitude of w is square root of 5. So 2 over the square root of 25 times 5 is approximately 80 degrees. And just one more thing I want to follow up with. In terms of the three problems we had, we saw in example A that the dot product was negative and our angle resulted in 150 degrees, or 5 pi over 6. In example B, our dot product was 0, which was a 90-degree angle. And in example C, our dot product is positive, which resulted in an acute angle. So really, you'll have an idea of what kind of angle you should get from the dot product alone. So if your dot product is positive, that's going to always give you an acute angle between 0 and 90, or between 0 and pi over 2. If your dot product is 0, it'll give you a 90-degree angle, or pi over 2. And if your dot product is negative, like in example 3a, then your angle will be obtuse. So just by looking at the dot product, you'll automatically get an idea of what kind of angle you should have, an acute, a right, or an obtuse. Alright, so that about does it for this video. I'll see you in the next video for projection.